Hello everyone and welcome back to my channel. It has been like, what, 7, 8 months since I last recorded a video. And that has mostly been due to work and school obligations. I've just been pretty busy overall, but I am really excited to get back into recording YouTube. I'm hoping to be able to put like 15 to 20 minutes every day into recording and editing, which should roughly translate to like one video every 3, 4, or even, a week, one video a week on the conservative side. But I'm really excited to get back into this, and at least for the next few weeks, I'm going to be testing out like my upload frequency and stuff like that. But in today's video, we're going to be going over the AP Computer Science A FRQs. More specifically, we're going to be going over the 2017 FRQs question 1. And the reason for that is last year I did some prep with some people prepping for the APCSA exam, and that's one of the questions that I already did. So it's going to be easy to just record and explain and start with that. But in the future, I am planning to go over different questions and different FRQs, so stay tuned for those. So without further ado, let's go ahead and get straight into the video. All right, so we're going to go ahead and get started by going over the first question in the 2017 FRQs. So this is where we're going to be writing our code. And I just made a little checklist for myself here. And we're going to start off by reading through the problem and noticing the keywords. So I'm going to go ahead and pull up the PDF here. This is the 2017 test. And please note, I'll go ahead and do this part right now. If you are taking the test in person, you're going to have to write this on paper. And if it's online, you're still going to have to type it into a text box. And basically, you're going to have to write this code without autocomplete. So keep in mind that you're not going to have like an IDE editor. You're literally going to have a piece of paper to write your code on. And this will be a sheet of paper, or this will be, a stack of papers that you're going to be reading from. Just keep that in mind. So going into the question right here, we want to start reading it. This question involves identifying and processing the digits of a non-negative integer. Now, that's just one thing to keep in mind. It may or may not come in handy in the future. We will see. The declaration of the digits class is shown below. You will write the constructor. So that is one of our tasks, and one method for the digits class. That's the second task. And you'll notice down here, it's actually 1A and 1B are those two tasks. So that's what you will be doing in this question. So we can go ahead and take a look at the class declaration. We have public class digits, and then it has a private array list member called digit list. It has a constructor, which takes in an integer number, and then it has a member function Boolean that returns a Boolean called is strictly increasing. And then it does some explaining here in the comments, and you can read over that if you want and go ahead and pause the video. But basically, this is what we have to work with. So I'm going to go ahead and come in here, and first thing, I'm going to go ahead and just copy this class digits. And then, so we had a private array list of integer called digit list. And then we had a public digits taking in an int num. And then we had a public Boolean called is strictly increasing. And that one just did that. And then, you're not going to have to do this on the actual test, but because we are running this in a code editor, I have to import array list. So I'll go ahead and do that right here. And it's also a good thing to note that we will take a look through the CSA reference. You will be given this sheet of paper on your test, and this is basically a reference to all of the things that you need to solve the APCSA questions. So it has references for strings, integers, doubles, math, array list, which we are working with in this question, and object. So this is a good thing to keep in mind. Like if you want to know how to do something with an array list, then you can take a look at the reference here, and then you'll see it has a size function. It has an add function, a second add function. It has, a get, a set, and a remove, and it tells you what these things do. So you have this all available to you on the test, so you don't have to memorize what all of these functions are. You still can take a look at them. So just a quick note on that. Now, after implementing the class, I'm actually going to go ahead and just go into some review of some computer science topics in general for Java before we actually dive into the solution for this. Now, if you are already familiar with the array list or modulus or while, I will put the bookmarks down in the video. I'll bookmark the times. That way you can go ahead and skip this section. But we're going to start off by reviewing array list. Now, the way I've set up this code is I can just write some code in this playground run function, and then we can get rid of it after. So we're going to start off by reviewing array list. I'm going to go ahead and import that here too. Okay, perfect. So let's go ahead and create an array list of integer like we had over here, and then we'll call it list. And I'll go ahead and just run this real quick to make sure we're all good. Oh, whoops. In this function right here, let's go ahead and just return false for now because we haven't implemented it yet. Just ignore all of this for now. But just to make sure our code is compiling, good. So basically, an array list is literally a list of anything. In this case, whatever you put in between these angle brackets, integer, for example, will be what it is a list of. Now, if we take a look at the reference here, an integer is an int. It's equivalent to that int thing, the lowercase that you use for variables. And basically, what is an int? It's just a whole number, negative or positive, except in this question, we know that it will be non-negative. So basically, it's just a whole number, negative or positive, and then it's a list of those things. So essentially, the notation we use is we use these 8 square brackets right here, and then we could do 1, 2, 3, and 4. So this is a list of 4 numbers, 1, 2, 3, and 4, and then we could add 10. So this is a list of 5 numbers, 1, 2, 3, 4, and 10. And that's basically what an array list is. Now we initialize it by saying new array list of integers, and then just doing that. So this will just create a new array list for us. Now, what we can do is we can go ahead and take a quick look at this reference here, and we see array list has an add function, which basically takes an index and an object, or you can just run add and then just the object itself. But we're going to be using the index one for now. Just we can say list.add. And then notice in Java and in a lot of languages, indexes start at 0. So instead of this being the first item, it's actually called the 0th item, and then this is the 1 item, the 2 item, the 3, and then the 4. So it starts at 0. So we can add the number 1 to our list. And then if I go ahead and print system.out.println our list, we will see what happens. If we take a look at the console down here, you'll see what we get. Oh, whoops, I missed a T, my bad. If we run it again, and then we'll see that we get square brackets and a 1 on the inside. And that's the reason for that is that we ran list.add 0, 1. Now, if we go ahead and run list.add 0, 2, basically what we're going to do is it'll add a 2 before the 1. Since we're adding it to the 0th index, that's the first index. Basically, it will have 2 and then 1. And then we can run list.add without a second number. So if we just want to add 3, what this will do is it'll add 3 to the end of the list. It'll automatically just go to the end if we do not specify where to put it. So 2, 1, 3. And then, of course, let's just say we want to add a 5, just to show you an example. As the second number, we would put it to index 1. Because again, if we want to make it the second number, we put index 1 as the first thing to add. And then it'll be 2, 5, 1, 3. So that is basically what array lists are. And then, array lists have other functions like get, which will basically tell you what element is in that position. So if I say list.get 0, it'll return 2 because 2 is in the 0th index of the list. And then we can use set, which is the same thing. It just updates one of the numbers. So if I set 0 to like 9, then instead of 2, it'll be 9, 5, 1, 3. And then we can remove a number from the list. But all that really matters for this question is the add function. So that was a quick overview of the array list data type. And then another review of what's called the modulus operator. We'll take a look at that. So I'm going to go ahead and just fix this comment right here so that we have 2, 1, 2, 5, 1, 3. And then, so I'll just comment this. This will be like array list review. And then down here, we're going to go ahead and do modulus review. So go ahead and just ignore the system.out.println. Actually, I'm going to go ahead and remove it. So modulus is a whole nother different thing, and it has to do with division. So when you think about like int results is equal to 10 divided by 5, what you think about is 2. Obviously, 10 divides by 5 twice. And that is division. It's this slash right here. That's what it stands for. But there is another thing that we could do. For example, 10 divided by 3 is equal to 3 if you floor it, obviously, because 3 goes into 10 three times, and then it also goes in 1/3 times. And if you remember, I'm not sure if you learned, but in elementary school, what's often taught is 10 divided by 3 is equal to 3 remainder 1. If you think about it, R1 or whatever, 3 and then a 1 remainder. So what that means is you get 3, but then there is 1 remaining that cannot be divided evenly um, into a 3. So basically, what the modulus does is we could say int mod result equals 10, and then the modulus operator is this percent sign 3. What this is equal to is 1. It's basically the remainder operator. It gets you the result of the modulus is the remainder of the division. So another example of that, and of course, this is not valid code. I can't have two equal signs. This is just an example. But if we have something like 9 divided by 2, well, obviously the answer is 4 because 2 goes into 9 4 times, but 9 modulus 2 is equal to 1. And the reason for that is if you divide 9 by 4 or 9 by 2, you'll get 4 remainder 1 because there's 1 left over. And then we could do something along the lines of like 9 um, modulus 7, for example, which is equal to 1. 9 divided by 7 is 1, or sorry, 9 divided by 7 is 1, and then 9 modulus 7 is 2. And the reason for that is when you divide 9 by 7, you get 1 and you have a remainder of 2 left over. So basically that's what modulus is. And then what we're going to do is we're going to go ahead and say 3, and then this is equal to 1, and so on. So that is basically what a modulus is. And that's an important concept specifically in this question. And then finally, just a while loop. This one is the simplest. Whoops. It will loop, for example, we could say int counter is equal to 5. We can say while counter is greater than 0. So, if the counter is greater than 0, then this will keep running the code on the inside. So we could say counter equals counter minus 1. And, I know there's many different ways to write this. You could write counter minus minus. You could write counter minus equals 1. But for sake of brevity, or opposite, for sake of just writing everything out, I'm going to write it as this. Counter equals counter minus 1. So every time that this code runs, the counter will decrease by 1. It'll go 5, and then it'll go 4, and then 3, 2, 1, and 0. And when counter is equal to 0, this will no longer be true. So we can go ahead and system.out.println I. And you'll see that this will run 5 times. It'll run 5, 4, 3, 2, 1. 5, 4, 3, 2, 1. And we can actually print, for example, the counter variable to show you counter. And all this is doing is it is running a loop while this is true. And you'll see counter starts off at 5, and then, it becomes 4 because we decrease it. And then it becomes 3, it becomes 2, it becomes 1. And then when it becomes 0, this condition is no longer true. Counter 0 is not greater than 0, so it will stop running this code. So that is simply the while loop. So now that we have all of those concepts out of the way, we are able to go ahead and get started with our solution. So to take a look back at our question here, what we need to do is we need to essentially create the constructor. So write the constructor for the digits class. The constructor initializes and fills digit list with the digits from the non-negative integer num. The elements in digit list must be integer objects representing single digits and appear in the same order as the digits in num. So for example, if we created digits with 15704, the digit list variable, that member variable inside the class, needs to have in its 0th index, it needs to have 1. In the first index, it needs to have 5704. So basically what we're doing is we're taking a whole number and we're splitting it into its individual digits. And that's what we're doing in the constructor. Now, when you're actually going through this on the test, it's really just important to know all the fundamental concepts of Java. And for example, knowing how to use an array list properly, knowing how to use the modulus operator, and knowing how to use the while loop is literally just a must. You just need to know these things, know them beforehand, And that's the reason why you want to review as many fundamental concepts as you can in preparation for the APE test. Because, for example, the modulus operator doesn't show up here. You don't know about it unless you learned about it. So it is one of the fundamental concepts in Java. So it's just important to know all of these, because without the modulus operator, this solution is not feasible in the time that you have to write the solution. So to get started, we're going to go ahead and take a look in this constructor right here. This is what we're writing. We are writing inside these brackets. So what we're given is an integer called num. And for example, we'll say num is equal to 15704. In this example, it could be equal to anything though. And then what we need, digit list must equal 1, 5, 7, 0, 4. So what we need to do, this is not like true right now, but it must equal 15704. Now, the first thing I'm going to do is I'm going to go ahead and initialize it. Don't forget to do this. This is a very important step. Basically, whenever you have a digit list, like whenever you have a member variable, you need to initialize it to an empty list first. Otherwise, your code will not work properly. And then after you have done that, now you need to basically propagate it. So what we can do is we can do digit list.add. And then remember, we could add to the beginning 1. And then we could do digit list.add. We could add 5. Digit list.add 2, 7. Digit list.add 3, 0. And then digit list.add 4, 4. Boom. And then if we were to do this and then go ahead and system.out.println digit list, we will go ahead and take a look at what that does. And what I'm going to do for now is I'm going to go ahead and comment out our playground code. I'm going to create a digits d1 is equal to new digits 15704. And you'll see this syntax right here is literally a copy of this line right here on the FRQ. I'm going to go ahead and run this to show you what happens. And basically, what we will get is 15704. Now, how do we do this? We literally manually put 15704. But what if I change the number 157 or 421313, for example? If I run this again, it's still going to print 15704. The reason for that is we've hard-coded the number. So obviously we can't do this, but this is the concept right here. This is what we need to do, in the case that it is 15704. We need to figure out how to generate this code without actually baking it in. So how we do this is using the modulus operator. Now, if we recall, 10 mod 7 is equal to 3. And the reason for that is 10 divided by 7 has a remainder of 3. Now, there's a pretty interesting property that we see. If we mod 101 by 10, if we mod anything by 10, you'll see that the answer is 1 in this case. Whoops. If we mod 107 by 10, we will get 7. If we mod 109 by 10, we will get 9. 103, same thing, we will get 3. And you'll see a pattern here. It's basically extracting the last number. And why is that? Well, obviously, because 100 divides evenly by 10, so all that's remaining is the last digit. And it doesn't matter how many zeros you have. You could have 1001 mod 10. It'll still be, or whatever number mod 10, it'll still be 1. For the reason that no matter how much you have back here, it will all evenly divide by 10. 99999 evenly divides by 10, so all that's left is that 1 for a remainder. And that's the reason why modding 10 will get you the last digit in the number. Now, the way we can use this is instead of digit list.add 0, 1, we could add to the 0th, we could add digit list, num mod 10. And if you think about it, this is where we're starting to get somewhere. This will add the 4, basically, and it'll be a 4, or 15704, like that. Let's go ahead and rerun that. And instead of being a 5, this will be a 4 now. And it'll just be a 4 in the array. Now, the reason why this works is we are now using the variable mod 10, which will get us the last digit. Now, we need to figure out a way that we can run this every digit and then also get it in the right order so that the first digit is first instead of the last one. So how we can do this is, again, using the while loop now. So what we can do is we can say while num is greater than 0. So basically, num is greater than 0 right now. We want to keep running this code. we can capture the last digit by doing num mod 10. We already established that. Doing num mod 10 will always get us the last digit in num. Even if it's just 1, 1 mod 10 is still 1 because obviously, you know, there's a remainder of 1. 1 divided by 10 is 0, remainder 1. So what we do is we get the last digit, and then what we're left with is 15704, and then the last digit is 4. Now, how do we basically get the second to last digit? Well, if you think about it, we could figure out a way to cut off the 4 here after we extract it because we already have it. We don't need it anymore. Now we're left with 1570 and we can extract that 0. And then what if we could cut off the 0 and just be left with 157? Then we could extract the 7. Then if we could cut off the 7, we could extract the 5. And if we could cut off the 5, we could extract the 1. And then we could get the 15704 this way. Now, how do we cut off a number? Basically, if you think about it, all we have to do is we have to subtract the 4, subtract what we get here. We're left with 1570, 0, and then we need to divide by 10. And what we're left with is 1570. If we go ahead and extract the 0 now from the n, and we do 1570 minus 0 is equal to 1570 divided by 10, then we're left with 157. If we extract the 7 and then you repeat 157 minus 7 is equal to 150 divided by 10, we're left with 15. And you'll see this is kind of a loop that we could do over and over and over. And eventually, if we continue this loop, we can extract the 5. 5 minus 5 equals 10. Divided by 10 is equal to 1. Finally, 1, we can extract the 1. 1 minus 1 is equal to 0. Divided by 10 still equals 0. Now, with the 0, num is no longer greater than 0, so our code will stop running. So basically, we can use whatever is in this loop to create our list. So what we want to do is we want to get this last digit, and then we want to digit list.add 0, last digit. What this is going to do is it will continuously add whatever the last digit is to the beginning of our list. The reason why this is important is because we start off with 4, and then we go to 0, and it'll add it to the beginning. Then we go to 7, it'll add it to the beginning. Then we go to 5, it'll add it to the beginning. Then we go to 1. And suddenly our list is filled with the numbers that we want. So we're going to go ahead and add like that. Then what we're going to need to do is we're going to go num is equal to num minus last digit divided by 10. And then we need to use parentheses for order of operations. We want to subtract the last digit and then divide by 10. And then we want to repeat over and over and over. And if we are done and if we have implemented this correctly, you will see this print right here will print out 15704. 15704. Now, if we go ahead and do a random number 321, 321, for example, you'll see our array contains 321, 321. This is an algorithm that works for every number that you can give it that is non-negative. So basically, this has been the walkthrough of the solution. If you do have any questions, any additional questions or anything, you can go ahead and leave it in the comments and I might I will either respond or if there are enough, I guess, questions, I can make a future video reviewing just other AP concepts in general. I am planning to go through and walk through the B part of this question, but this video is already getting a bit long, so that will be its own video. These walkthroughs do go very slowly, and that is on purpose because obviously I could do a quick walkthrough and then leave you with 100 questions, or I could go through very slowly, explain the exact algorithm that we're using and explain the implementation of that algorithm, and then, call it that, and then just make more videos that will cover the topic slower. Of course, you can watch it at a higher speed or you can skip around if you want. But basically, that has been the constructor for digits or question 1A on the 2017 FRQs. So I hope you enjoyed the video. If you enjoyed it, please give it a thumbs up. Subscribe if you want to see more content like this. I am planning to come out with more AP guides, more specifically for APCSA. We're going to go ahead and continue going over the 2017 FRQs in future videos. But I hope you liked it. I'll see you in the next one.